So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 26th of the June Daily Code Challenge and we have a medium level question in front of us. Previous few questions were on the harder side, but let's see this medium question. This is basically on the priority queue data structure. There are many ways to do it, but the easiest way will be to do is using the priority queue, and let us see what the question is. So it's question 2462. Total cost to hire K workers. Okay, total cost to hire K workers. So you will be understanding K will be the input given to us. You can see the input here. So K is actually the given input to us. Then there are something called candidates, is also integer, and there is an integer array called cost. Okay, we'll understand what each of these means, and before that, I will again say that if you're not aware of what a priority queue is, and especially in Python, when we talk of priority queue, it is implemented using a heap. Okay, this priority queue is basically a heap. Okay, that's how it is implemented. And if you're not aware of these things, please do a Google search once and get to know the basic idea of it. Okay, so going to the question, we are given a zero index integer array called cost. You can see here I have highlighted here cost, where cost of I is the cost of hiring the ith worker. Okay, for example, if I hire this worker, so the cost to the company will be 10. Okay, 10 units. That's what they are trying to say. Okay, we are also going to integers k and candidates. Okay, we want to hire exactly k workers according to the following rules. So two things are very clear here. This is the cost array of each candidate. Okay, so suppose I hire this candidate. Sorry, yeah, the candidate marked 20. So what will happen is I have to pay 20 units. Okay, so 20 units has to be paid. Okay, that's the basic idea. But see here the number k is given. That means this many candidates only I need to hire. Okay, this many candidates only I will be hiring. So I have to pay cost for three candidates only. That's the basic idea. Now this is another term given to us. Till now we have not seen what is the use of this. We will see that now. Okay, so yeah, we will see that now. Where you will be here, okay, you will run k sessions and hire exactly one worker in each session. Okay, so there will be k sessions. In each of the sessions, we will hire one of the workers. In each hiring session, choose the worker with the lowest cost from it. So now comes the see, now this thing is coming. What it means is, see, idea is very simple. For example, here a candidate is equal to 4. What that means is, see, take the first four workers. So the first four workers here. Okay, similarly take the last four workers here. Okay, so you can identify that, yeah, this is how it is. Okay, this is the underlined ones: 17, 12, 10, and 2. Okay, then 2, 11, 20, and 8. Okay, what we did, we took the first four workers and the last four workers. Why we are taking four? This where the four is coming from. This is the four from where it is coming. Okay, so this is the given input to us. What we are doing is we are taking the first four candidates and the last four candidates. Okay, then what we have to do? Then we have to, let's see the question. That what yeah, for example, and yeah, this is the given array candidates equal to. So yeah, in the second hiring session, we will choose first worker. Okay, so what is happening is, see, after selecting the first four and the last four, we have to choose among those the selected ones which has the smallest value. Okay, suppose this value and this value is same. Okay, so what we'll do, we have to select it based on the one which is having the lowest index. Okay, I will again repeat. See, this is the array of cost given to us. Okay, we are going to hire these many candidates. Okay, but how the hiring is going to happen in a puzzled way. So what is that puzzle and what are the conditions? See here, what we'll do is we will select the first four candidates. Why four? Because four is coming from here. Okay, select the first four candidates in this array, select the last four candidates in the array. Okay, now the second round, the selection will happen among these only, the first four or the last four. Among them only one will be selected in a round. Okay, so what will happen, see, among these four and among these, so because totally we have eight, right? Among these eight, we have to select one worker. Okay, what will be that worker? That worker is the one which has the lowest cost. Okay, the worker is the one which has the lowest cost. In case there are two workers, so we have to select the worker with the lowest index. Okay, that's the basic idea. So let's see, we'll trace it, that you will understand that. Okay, so you can see 17, 12, 10, and 2, and in this case you can see 2, 11, 20, and 8. Okay, you can see that 2 and 2 is common. 2 is common in the left one also, 2 is common in the right one also. Okay, right 4 is also, 2 is common. So what we have to do, we have to select the 2 with the lowest index. Okay, so the lowest cost is 2. Okay, and we break the tie by the smallest index. Okay, which is 3. Okay, you can see that this 2 is basically index 3. Okay, this 2 which you are seeing here is basically index 3. So the current cost becomes, initially it was 0, now it became 2. Okay, 2. Now come to the second round of hiring. Okay, in the second round of hiring, remember one thing: once you have chosen that 2, the index 3, now that 2 should be removed. Okay, that 2 cannot be selected again. Okay, that's the basic idea. Now in place of that 2, you can see that 7 is coming. Okay, the 7 which is here, see, this 2 will be removed, right? After you remove the 2, 7 will come to that, okay, portion. So it will be now in the first 4, okay. It will be now in the first 4, and these are the same, okay. The last 4 is the same again, right? So among them, now I will select the smallest. Again, you can see that 2 is the smallest. 2 from the right part, right group is the smallest. So that will be now taken, and the cost for that will be added now. So the total cost will be 2 plus 2, which is 4. Okay? 2 from the previous iteration, 2 from the second iteration. Okay. Now comes the third round. Okay. What will now? So remember, this 2 will be removed. So what will happen is, see, once we remove 2, we will not have 4 from the right. Sorry, 4. See, there are two groups, the left group and the right group. Okay, you can call it header and tailor. Okay, so the left part, see, this 4 is called the header, this 4 is called the tail. Okay, so once I remove these two, I will not have this many number of candidates in the tailor group. Okay, so in the tailor group, it won't be there. Okay, so you can see here, this has 4, this has 4, but this has only 3. So that also is fine. What we will do, again the same thing, find the one which has the smallest number, and if more than one has the smallest number, then we have to choose the one based on the lowest index. Okay, and clearly 7 has the smallest number, so we will add it to our answer. 4 was the 4 we had till now, which is 2 plus 2. Now we'll add 7 to it, so it becomes 11. The 11 is going to be the answer. Okay? That's how we're doing it. You can read this question also. They've given some examples here. In the hiring session, choose a worker the lowest cost from either the first candidate workers or last candidate workers. Break the tie by the smallest index. They've given us some sample here. Okay, they are given candidates equal to 2, so we have to select the either the first two. So among the first two or the last two. Okay, so among these 4 only we have to select. Okay, so the first hiring session, we choose the fourth worker. See which is the fourth worker. See, this is the fourth worker. Okay. So we basically one. Okay. This is the one will be selected because it has the lowest cost. In the second hiring round, we will choose the first worker, which is, yeah, this one. In the second hiring round, okay. Because one is removed, so now the next smallest is this because it has lower index. You know that index may be changed in the process. So remember one thing. Once you remove one, it will be totally removed. Okay, so its index will also become, so the element to its right will be occupying that. Okay, that is the basic idea. So the indexes will also change once you remove something. Okay, that's the basic idea. If there are fewer than candidates workers remaining, choose the worker lowest. Uh, Choose the worker with the lowest cost among them. Break the tie by the smallest index. Okay. Remember this thing. This is a very very important one. A worker can be chosen only once. Return the total cost to hire exactly gave workers. So if you would have understood this question correctly, I see. First of all, this question is difficult to understand. I will definitely expect you to read this question word by word. I will give you the link in the description. Please read this question word by word. Then please pause this video right now and rewind it and see again. You will definitely understand what it means. It's a very simple thing. We are given a cost array, but the hiring will happen in a very tricky way. What is the tricky way? We will be hiring among the, let us call this candidates equal to m. Okay, let's, whatever is the candidates array, let me call it as m. Okay, so the hiring will be happening as that we are going to hire one worker out of the left m workers and right m workers. Okay, that means total we have 2 m workers. Out of those 2 m workers, only I am going to hire one. Okay, not among all the workers. Okay, only the workers, m workers towards the left, m workers towards the right. Okay, among them only one of them will be hired in a single round. After it is hired, it will be removed from the array. We'll again calculate left m and right m workers, and again out of those 2 m workers, we'll try to find one. Okay, there will be a time when we will not have 2 m workers. That is, either the left or the right m workers will have somewhat less. Okay, it won't be m as such. Okay, it may be m minus 1 or m minus 2, something like that. In that case, also we have to continue the same logic. And one thing here you have to remember is that whenever there are two numbers, so suppose, as I said, we have to going to find the smallest. So suppose there are two numbers with the smallest value, then we have to select the one which is the lowest index. Okay, so that is something important. Now coming to the coding part. Coding part, as I mentioned, we are going to use the priority queue. If you talk about Python, in Python we are going to use heap. Okay, heapify function to make heaps. So priority is basically implemented using the heap, okay? And especially mentioning, if you are like aware, if you are a computer science student, you will be knowing these things very well. We are basically going to use a min heap, okay? Why min heap? See, it's very clearly mentioned. I need the, see, among, suppose m equal to 4. What is m? M is equal to going to be the candidates, okay? Suppose m equal to 4. Then I want the smallest among the first 4 or the last 4, okay? So we will be using heaps, sorry, min heaps. Okay, so what the idea here is, see, we'll be using separate heaps for the left 4 and separate heaps for the right 4. Okay, so That's what we are doing. Yes, see, we are using two one. What is first one is called head workers, and the next one is called the tail workers. Okay, head workers will capture the M candidates from the left, and the tail workers will capture the M candidates from the right. Okay, that's the basic idea. Yeah, tail workers or the last K workers. Remember one thing: without any workers from the first, that means each the head and tail worker should not overlap. That means there should not be any worker which is both in head and tail. For doing that, we are doing a special trick here. I will mention that trick too, but let us see the code first. Okay. See, cost of see what it means is, remember one thing. See, this is something which I don't like. They are calling it candidates, but it's a very vague name. It should be named as M. Okay, I will throughout this solution I will call it as M. Okay, so what is happening? See, cost till M. Okay, suppose see the example here. This is the cost array. Suppose I'm equal to 2. Okay, here M is equal to 2. So I when I say 2 here, that means the index 0 and 1 will be selected. So 0 and 1 will be selected. That's why I am through this I'm ensuring that the first two workers are selected. That is first M workers are selected. Now comes the tricky part. See there for the tail workers, I'm doing some conditioning here. Okay, I am taking the max of either this or this. Why I'm doing like that? Remember, I told you they should not be overlapping. For example, see, I will tell you the case here. See, there are how many elements? There are six elements in this. Okay, there are six elements in this. Now, suppose I'm equal to five. Okay, not five. Let's say four. Suppose I'm equal to four. Okay, this four, okay, it's coming perfectly. But what about the tail four? Okay, what about the tail workers? You will take these four. You can see that these seven and seven are getting overlapped. See, this is the head workers, four workers, and these are the tail workers. But you can see seven and seven are getting overlapped. Okay, how to avoid that? Okay, how to avoid that? That is how what we are doing here. Okay, we are taking the max of candidates. Okay, max means see it will take the rightmost index. Okay, either this is the rightmost index or this is the rightmost index. It will take that. Okay, I will show you the actual calculations also. See, length is equal to 6, right? Length is equal to 6, and suppose I'm equal to 2. Okay, now what will happen is I am going to take from the fifth, sorry, length equal to 4, right? So from the fourth index onwards, which is the fourth index, 0, 1, 2, 3, and fourth index onwards, I have to start taking from this onwards. Okay, for the tail workers. Okay, this is correct also, right? Because 3277 came to the head workers. Okay, after that only I should not take 7 and 7 again. So this code will ensure that I do not overlap. Okay, this will ensure that. Okay, in this case, if you calculate the length of course minus candidates means length of course is 6, candidates is 4, 6 minus 4 is 2. Okay, if you start from 2, which is this worker, you will see that it's getting overlapped. Okay, so that's what I'm saying. You will take the max of these. Okay, either this or this, whichever is the max. That is, whichever index is coming to the more right of, so whichever index is coming more towards the end, that will be selected. Okay, I explained you when this works. This will work when there is overlapping happening. This will ensure that there is no overlap happening. Okay, this will ensure in normal case this will be working. Okay, if there are enough m elements towards the right, then this will work. Okay, I hope I've given you enough justification, and I've given you a simple example also where I'm equal to 4. Then we will use the heap function. What is heap function? See, first we have made an array, right? We have just made arrays. These are arrays having m elements. Okay, the first m elements and the last m elements. Okay, head and tail workers. Okay, now when we talk about a heap is basically a data structure, right? So what happens is the zeroth element of the heap will be the smallest element because we are going to implement a min heap. Okay, that's why we have to do initiation. We have to initiate a process first to make that happen. Okay, min heap. Okay, so this is what is a heapify function we are doing. So we are calling the heapify function on the left and the right heap, which is the head and the tail heap. Okay, next we are declaring answer, which will be our answer, which will be returning finally. Okay, now what will happen is, see, now we are going to have two pointers. Okay, see, because see, we don't know, right, where, see, suppose for example, see, these are the first two workers and these are the last two workers. Okay, suppose the mini element comes from this. Okay, the mini element for the first one will be executed, right? See, first the one will be removed. Once I remove that one, I need to fill something in, right, in the tail workers. Okay, because one is removed, right? I need to fill that again to ensure that there are enough workers in the tail workers. Okay, so I have to insert 7 there. Okay, so to ensure 7 is inserted, I need to make mark some pointers there. Okay, so the next head will ensure that the element to the exact left of the current, for example, first two workers are inserted here, right? See, first two workers will be initially inserted in the head workers. Okay, so the exact element to the next head, okay, it will be pointed by head next head. Okay, similarly the 1 and 2 will be inserted in my tail workers. Okay, so the exact element which is left, okay, which is 7, will be pointed by next tail. That is the basic idea. You can see it's still candidates means it will be till 0 to candidates minus 1. So See, till candidate minus one, right? So the exact next element will be candidate. So it will be a lot of this thing, and you can see here this will be starting from length of cost minus candidates. So we are just doing a minus one extra here, okay, to ensure that the element will there left is getting the next till pointer. Okay, now we'll see the code. Now we'll see the code. See, ultimately, as I said, see, one thing you have to show you is that remember K and candidates, okay, these are definitely going to be less than the cost. So there will never be a scenario where we cannot hire K workers, okay. So one thing is very, very clear. Definitely, we will have K, the number of hires we need will definitely be having more candidates than that, okay. So you never need to worry, okay. So I'll just zoom in once, yeah. So yeah, so this loop will run for k times. So each of this time will get a single worker. Okay, in this whole loop, after every loop we'll be getting a single hire. Okay, that's the basic idea. But please pay attention here. There are a lot of things happening here. Okay, so yeah, first we are checking that if the length of tail workers equal to zero. Okay, if that means there is no element left in the tail workers, then definitely the hire is to be happening from the head workers only. That is the basic idea. Okay. So, okay, if this condition is true, go and execute this part of the code, okay? Otherwise, execute this part of the code, okay? First, let us focus on this part of the code. When this code will execute it, either if length of the tail worker is equal to zero, okay, we will definitely execute this part of code. So, if this is true, we will execute this part of the code. Otherwise, if this is true, then also we will execute this part of the code. Okay, remember or condition is given. Okay, or means if this is true, execute this part of the code. If this is false, also still if this is true, then also we will execute this part of the code. Okay, so what is the second condition? We'll see now. Second condition has two parts because we are using and. Okay, so it has two parts. We are checking if length of hard workers is not equal to zero. That means the length of the hard workers should not be equal to zero. And remember the and condition, right? What is the and condition? Remember, we are going to come to this thing only when this condition is not true. If this condition is true, immediately will be going and executing this part, right? This condition won't even be checked. Okay, this condition won't even be checked. Now, if this condition is false, only then we will be coming to this part. Okay, so if this condition is false, that means definitely tail workers has some element. Okay, that's why this condition will not return a error, right? This condition will not return. See, everything I am telling you has a meaning. Okay, everything I am telling has a meaning. These things will be very, very important for you to code the solution on your own. Okay, please pay attention. Don't think like I'm simply explaining the unnecessary part. Every part I'm explaining has a meaning. Otherwise there is no worth wasting my time here, right? That's what I'm saying. Remember this condition, if it is false only then we will come to this part of the code, right? This part is false, that means definitely there is single element in the tail workers. That's why this condition will not return error. Okay, so what we're ensuring that there is definitely some worker in the head worker space. Okay, that's why this will not return error. Okay, see, this ensures this will not return error. Remember, if there are nothing in that and if we're trying to access zeroth element, it will return error, right? That's what it is. So we're ensuring that the head worker is not empty, and then we're ensuring if the minimum see, remember it's a minimum, right? So the smallest element of the head workers is either less than or equal to the smallest element of the tail workers, then we have to take that from. That means what will happen is we have to take the smallest element from the head workers and add their cost to the answer. Okay, that's what it is. Okay, remember that I have told this already, right? See the example here. See, this is the first two workers, right? 3 and 2, and these are the next two workers. Okay, we have to compare the smallest element of this with the smaller element of this. Okay, so 2 and 1, so which is smaller? Obviously one is smaller, right? So one will be then removed. Okay, so this is what we are doing here. Okay, if the smallest element of the head workers is less than equal to the tail workers, that means from the head workers space we are going to pop one thing out. That will be the cost of that will be added to my answer, and we'll be inserting another thing to the head workers. That's what is going to happen here. Okay, this is what will happen here now. Okay, head worker is from the head workers. Okay, I will pop it out and I will insert its cost to my answer. Okay, now I will do the refilling of the queue of the head workers queue if there are workers outside the two queues. Okay, so how to ensure that? We'll see if next head is less than equal to tail head. Okay, if next head is less than equal to tail head, I will again see. Initially, next head will be here. Okay, so initially next tail will be here. Okay, till next head is less than next tail. so still next thread is less than equal to next thread. That means there is still at least one worker which is not part of either of the queue. So we can insert that to whichever queue becomes empty first. Okay, heap will be pushing in this particular heap. Okay, we will be pushing this element. Okay, then we will update the next head by one. Okay, now suppose if this condition is false. Okay, that means remember there are two things happening. Either it is false or is equal to. See if one element, the smallest element of head queue workers is equal to the smallest element of tail workers. In that case, also we'll take the one from the head workers only. Why? Because one from the head workers will definitely have a lower index. That's the basic idea there. Suppose this condition is false. That means the lowest you know cost worker of the tail workers is much more smaller than the lowest cost worker of the head workers. In that case, the hire is going to happen from tail workers only. Okay, then this part of the code will execute it. We'll pop it out and add this cost to the answer. Okay, then the refill of the queue will be there if the workers outside the queue are available. If any worker is there outside of both the queue, then it will be included. Okay, if that's what we're ensuring. Okay, remember this condition and this condition are exactly the same. Okay, so we'll be now doing the hip push in the tail workers thing, but here we did in the head workers. Now we're doing the tail workers, and remember the next tail will be will remember here we added one. Okay, because it has to move to the right, but in this case we are going to move to the left. Okay, so we're doing next tail minus one. Okay, this part of code will ensure that we get a single hire, and we are going to run this code for k times because we want k hires. Okay, and as I've already mentioned, there will see definitely the number of candidates present is greater than k. Okay, this is the cost length which will reduce the number of candidates for who are opting for hiring is definitely greater than the k or equal to k. Okay, there will never be a case where we exhausted all the workers, but we are requiring more hire. Okay, that will never be the case. So you can need not have edge case there and checking for that. Okay, that's what is being done here, and finally we're taking the answer. Okay. So why we are using this heap, a priority queue or heap? This is to ensure that among the left M workers, we get the minimum. We have the worker with the minimum, cost. Similarly, in the right M workers, we get the worker with the minimum cost. To ensure that we are using heap. Okay. See, when we talk of heap, to build a heap of size n, basically you require m log m. Okay, this is the time complexity that you require, and for each further operations, see, try to understand this how it works. See, suppose there are n elements. Okay, but I'm going to make a heap of size m only, right? M. To make a heap of size m, first you have to run the heapify function. Okay, I will just add these things here. Initially, to make see, that's what we're doing, right? We are going to have a heapify function. This heapify function will basically take m log m time. Okay, it will take m log m time. Okay, then that's fine. Next is we are doing some pop operations. See, pop operation will happen instantly, but we are inserting elements also, right? We are going to insert the element like heap push. We are doing heap push will take log m time. Okay? Heap push will take log m time. So heap operation will take log m time. But remember, they are going to be done for the k times. Okay. See, this is also heap push. This is also heap push, but at time only one will be done in a single iteration. But they will be done for k times. Okay. It is going to be k log m. Okay? K log m. So if you take the total time complexity, it's going to be m plus k log m. Okay, m plus k log m. Okay, this is for the time complexity. If I talk about the space complexity, see, we are only using heaps. Okay, no other data structure we are using. Others are anyway O of one only because they are just variables. Okay, they are just variables, and we are using heaps. Okay, these are just variables wherein we are using two heaps. So basically, if you talk about the time complexity, it's going to be O of m. Okay, basically the real thing is 2 into m, but in terms of space complexity and in terms of big O notation, it's going to O of m, and this is going to be around O of m plus k log m. Okay, m plus k log m. So yeah, friends, this was all for today. I think I explained this to you correctly. See, this is for this heap function will take this much time, and remember, popping out of the heap will take over one time. That is fine, but inserting something into heap and ensuring that heap property is maintained will take log m time. Okay. After that, we are doing that for the k times, so k log m. Okay, that's what it is. So yeah, friends, that was all for today. If you have a better solution, please do let me know. If you have any doubts on the solution, please comment below. I will definitely find some time to answer your doubts and concerns. Thanks a lot for today. See you tomorrow.